Alrighty, for section 2.8, the last section in our unit, we're doing something called quadratic modeling. So we're going to use this to model real-world data with quadratic functions. This also helps us make predictions. We will be using the quadratic regression method on our calculators to do this. So if you don't have a graphing calculator yet, please go grab one from the front of the room. So we're going to start off with an example here. We've got the table shows the cost of a circular plastic wading pools based on the pool's diameter. Find a quadratic model for the cost of the pools given its diameter. Then once we have that model, we're going to use the model to estimate the cost of the pool with a diameter of 8 feet. So you see down here we've got different diameters. We've got a 4-foot diameter, 5-foot diameter, 6-foot diameter, and 7-foot diameter. The 4-foot diameter pool costs $19.95. The 5-foot diameter costs $20.25. 6-foot diameter costs $25, and the 7-foot diameter costs $34.95. So what we're going to use, I'm going to show this app on my computer that I'm testing out. We're going to enter this information into our calculator. So what you need to do is turn your calculator on, then press the Stat button. Now you'll see it both over here and over here. On the Stat menu, we're going to go to Edit, so you can either press the number 1 or move your arrows up and down to select it. So we go number 1, hit Enter, and here's our area we're going to enter in the information. You'll see we've got L1 here and we've got L2 here. In L1, we're going to put our independent variable, and in this case, that's going to be our pool width, or our pool diameter. So we're going to enter those in for time purposes. I'm going to just do it on the keyboard on my computer. So we got 4, 5, 6, and 7. Then we're going to go over to the right, and we're going to enter in our costs into L2. So we got $19.95, just waiting for it to catch up, $20.25, $25, and $34.95. So double check your numbers, make sure you have the same number of values in L1 as in L2. So L1 is our first list, L2 is our second list. Now we're going to go back to Stat. And instead of choosing the Edit menu this time, we're going to go over to the right and we're going to go Calculate. Now this process that we're doing right now is called quadratic regression. So we're going to go down to number 5, the one that says quad reg. That's short for, overclicked. That's short for quadratic regression. And we're going to hit Enter. Now what it's asking for here is, it says our X list. That's our independent values. We put that all in L1, so we can leave that as is. Our Y list, which we put our dependent values, we put that in L2. Don't worry about frequency list or the way we can store it. I can show you those tricks later, but for today we don't really need it. We're going to just go down to Calculate and hit Enter. And you see it's going to give us some information here. Now we're going to take this information in a second, but one thing I want to acknowledge, I'm going to go back to the notes for a second. In our notes, it shows us that same information, but it has this r squared value. That r squared value is called our regression coefficient, and I'll write this down in a second. It's called our regression coefficient, or it's our correlation coefficient, regression coefficient, same thing. What we want, we're going to use that to determine how accurate of a function this is. But in order to get that, some of our calculators will already have that, some of our calculators will not. If you go to Mode on your calculator, go down for a bit, and we want to go to Stat Diagnostics and turn it on. So turn it on, highlight enter, or highlight on and hit Enter. Now we're going to try that same thing again. We're going to go to Stat, go to the Calculate menu, and we're going to go down to option 5 for quadrag and hit Enter. Again, same thing, L1, L2 for X and Y's. Leave the frequency list and regression or storing alone. We're going to hit Enter, and now it's going to give us all that information. So let's go back to the notes, and we're going to translate what that means in our notes. So we have, and I'll zoom in on this, we have, it says quadrag, and it says y equals ax squared plus bx plus c. What we need to do is take the a's, b's, and c's, so take this a, take this b, take this c, and plug them in. So let's jot down what this function actually would be. We're going to have it as y equals 2.4125 x squared, so plugging in the a value, minus 21.5625x plus our C value of 67.6375. Now it says our R squared value, again that's our correlation coefficient. Again, that's telling us how strong or how accurately this function, this quadratic function that we just wrote down, will model the data. It's not perfect. You can kind of treat it like think of it as a percentage. What we want it to be is we want it to be, sorry, misspelling. We want it to be close to either +1 or -1. In other words, we want the absolute value of that R squared value to be about 1. So the closer it is to 1, the better. This one's at 0.999. That's pretty darn good. We're going to get to some of this types of problems later, working with like cubics and quartics and other ones like that, where we're going to be comparing the R squareds, and we're going to say, okay, which one is the best? But for now, we can just look at it and say, okay, that's pretty good. All right. So now we're going to take that function. That's the function we could use to calculate the different costs. And now we're asked to take that function and figure out how much an 8-foot pool would cost. So let's go back to the calculator. We're going to take this information that we have. We're going to take it and put it into y equals. Now later on I'll show you a trick about how you could have it automatically jump or put that in there. But for now we're going to put this in manually. So we'll do 2.4125 x squared. Sorry, I think I pressed. Don't think it liked what I pressed there. Let me try that again. 2.4125 x squared. I don't know all the keyboard shortcuts on here for this. So minus 21.5625 x plus 67.6375. And let's take a look at our graph, and you'll notice we don't see anything. Let's think about why that is. And I'm going to go back to our notes for just a second. In our notes, our numbers that we were dealing with, we had diameters of 4, 5, 6, and 7. So those are our x values. We had costs of $19.95, $20.25, $25, $34.95. On our calculator, we don't see any of that. So let's adjust our window a little bit to see a little bit more. So go to Window. From Window, let's just change our y min to 0. Our x min to 0, because we're not looking for any diameter below 0, because you can't have a negative diameter. Now, we are asked to find something about when our diameter is 8. So an x max of 10, which means a diameter of 10, that's not a bad option. For our y values, let's just change it to a y value of a y min of 0, because really we don't need to worry about negative prices. For a y max, our lowest price that we are currently given is $19.95, so about 20 bucks. So let's just go a little overshoot and let's just try it out at 50 and see what this graph looks like to see if we can see enough points. All right. So there's our function. Now one thing we're missing on here is we actually have a way to show those points that we put into stat. So where we have 4, 19.95, 5, 20.25. What we can do with that is something that I've shown you guys before about how to get rid of it. But what I'd like to do is go press your up arrow and highlight plot 1 and hit enter. So now that when I get off of that, it has a dark background with light letters. So now that's going to take, plot 1 is going to take those values that we have in L1 and L2 and also put those individual points in the graph. So when we graph it, you'll see we've got those 4 points and our curve goes really close through it. Now, this being a calculator with not the greatest resolution, it's not going to be perfectly through it, but it kind of looks like it is. So this just kind of helps verify that our graph is pretty accurate for those points. It's not perfect, but it's pretty darn good. Now, the last question that we're asked to find is how we can get it with how we can figure out the diameter of 8. We already have this information in our calculator, so let's go back to the calculator. And let's just take a look at our table. Instead of having to go through, and we can always do this, instead of having to go through and plug in x equals 8, let's just go down to our table that's going to take our function for when x equals 8. So, taking a look at the table when x equals 8, let's translate that into a sentence. So when x equals 8, we're going to say the cost of a pool with and the x is the values are our diameter with a diameter, goodness gracious, of 8 feet is, and since this is not perfect, we're going to say is about $49.53. Goodness gracious, learned around, Mr. Brasser. 54 cents. I was not paying attention to the last decimal place. So that is one way we can go about finding this information. I would like you to try example 2 on your own before you move on to the next video.